I hear evolution happens every day. Is that true?
Hi everyone, my name is Ptara, and I'm a baby pteranodon. I have a lot to learn before I can join my flock. All my teachers work real hard to teach me.
Maybe?
That's a parrot.
Almost. It's a toucan.
It's a toucan.
Yes, and we have a bunch of different examples of toucans here. Yeah.
Toucans, that means toucans can fly.
Yes, they can. And what do we think toucans can eat? What do birds eat? What do we see here?
Cherry.
Yes, yeah. So they eat fruits and stuff. So when they eat the fruits, they put it in their tummy and they digest it, and eventually they have to poop it out.
Why did it die?
Oh, because he's old, that's why. But after they poop out those seeds, they turn into trees. And that's why toucans are really important. And we show here in this cool little diagram how in the 1950s there was like a ton of trees and stuff, and then eventually because of like farming and people, we get less and less trees and forests, and their habitats are going away. So this booth is kind of just talking about deforestation, and then he has like a really cool video to show you guys if you want to see it.
You want to see the video now?
So here we have a video of satellite imagery from Brazil. So this is going to be like the Amazon rainforest. And so back in the 70s, it was all rainforest.
Yeah.
But as you go into the 1980s and 1990s, start farms and cities pop up in the rainforest, breaking it up.
Isn't that wild?
So now instead of having a big piece of rainforest, you've got all these little patches, which this little cartoon demonstrates. So here you've got the big forest, and then you have the little forests here. What is one of the big things you see with the animals between
what's the
this
difference
one
between the
and this one?
What do we see?
That one, that one.
So more animals here, less animals here.
What about the sizes of the animals?
And the sizes,
You
what
see
about
these big
this?
ones?
You see the big ones, they are not here no more. They don't have enough food.
That's exactly one of the reasons.
Yeah.
So when they don't have enough food or shelter, they can't live in those areas. And because they can't get from one area to the other, they can't get enough food. So basically these are essentially islands, because you have like a big city separating the two. It's a lot similar to what happens with actual islands, such as the Galapagos, where you have all these different islands that have different habitats and different types of food on them. So these are Darwin's finches,
Wow, that's
who
cute.
Charles Darwin studied.
It's a dollar question because they're so cute.
And so you had a few finches at the beginning, but as they lived on these different islands, their beaks specialized to eating different types of foods. So these ones with the broad beaks, they probably had beaks
They
that are
have
very good
beaks.
for eating seeds.
That is a seed.
So we can see that here in all these cool beaks, how they each have a different beak because they specialize.
And different food.
Exactly, exactly.
So cute.
I think it's called a quetzal, is the
Quetzal.
common name.
That's how to cut them. They have what tails.
Yes, so these tails are used for mating as well. So they'll start dancing and showing off to the females, and that's how they've evolved to tell the difference between birds so they can find their friends.
They poop eggs.
Oh, they poop eggs. But they do have eggs because they're birds. But yeah, so you see all the different beak sizes have evolved for a different type of food. So that's what we're talking about here.
here we have the domestic dog. This is some sort of terrier. I'm not sure exactly what it is. And then the big one back here is actually a wolf. So this is the ancestor of all modern dogs. So what happened was, about 15,000 years ago, 20,000 years ago, there's kind of a discrepancy there, we're not sure, human beings started hanging out with wolves, or maybe wolves started domesticating human beings, we're not sure how that happened. But either way, they started a partnership where they would take them out hunting and things like that. And then we started breeding the wolves, and we selected different traits that we liked. So whether they had good smell or good sight, whether they were large or they were small, whether they were furry or not furry, all those are different traits that we chose from those original wolves, and we actually made a new species. We made Canis domesticus from Canis lupus, and then we started making different breeds from that species, and that's how we ended up with all of our different dog breeds today. So, and then certain breeds made other breeds, and those breeds made other breeds, and now we have hundreds of breeds today, depending on what you like. Sometimes we bred different skulls, right? So some dogs, like greyhounds, have this more wolf-type skull, and then you get this medium-sized skull from German Shepherds. Those are, they have really good eyesight, really good smell, and you can see that they have a little bit larger eye socket, a little bit larger olfactory. And then other people have bred things like pugs and Pekingese and things like that because they think they look cute. I'm not one of those people, but some people do like them, and I guess some of them are pretty cute. Bulldogs are cute. They have that face, and those guys end up having usually a lot of breathing problems because they have that squished-in face. But we have bred those dogs to look like that. They don't look like that naturally. They came from the original wolf, and then over thousands of years of us breeding them in, we have changed the way their skull shape actually looks.
So Tara wanted to know how all of these different vegetables are related, because they look pretty different. There's cauliflower, broccoli, kale, Brussels sprouts, and cabbage. And if you just saw them, you would think, oh, those are completely different plants. They're completely different vegetables. But a fun fact is that they all started out as the same wild cabbage called brassica. So that's what this picture is up here. They all looked like this, and they have been selected for different traits, for texture, taste, and for nutritional value. So cauliflower and broccoli kind of look alike because they're both the flowers of the plant, whereas cabbage and Brussels sprouts kind of look alike because they're both the buds. So they're the flower buds before they actually reach becoming a flower. And then kale looks like a bunch of leaves because that's what it is. We bred them for eating the leaves in this case. So over time, they've evolved into different subspecies, but they all started out as the same thing, which is pretty cool.
All right, so earlier we talked about how dogs and wolves have changed as a result of humans over time, and at this station we talked about some of the other animals. Like this is a bobcat in front of me right here. It's a wild animal, obviously, and here's a bobcat skull and a lynx skull. But these two skulls right here, these are actually skulls that belong to domestic house cats, like the kind you see walking around your neighborhood. And, you know, just looking at them, other than the size, it doesn't seem like there's a whole lot going on in terms of them changing over time. But if you look closely at their teeth, then we start to actually see where these changes come into play. So in domestic cats, we have this like tiny little tooth behind the canine that's developed right there, and a wild cat like a bobcat, that tooth is completely missing. It is not there. So it's kind of interesting because over thousands of years, as humans and cats have lived together, as cats have gotten used to being around us, their diet has actually changed. When they were wild, it was all meat all the time. They didn't want it to do with anything else. But as they've lived with humans, they've actually started to put more plants into their diet, because sometimes it's just easier to eat the plants than to go hunting. And so you can see other changes in their bodies, like longer intestines to help extract nutrients from the plant matter. So even though they're not changing a lot on the outside, there's some major changes going on the inside as a result of living with people. Now, if you want a sign of a more obvious change, there is this guy. This muscle cow, which crops up on Google Images and social media from time to time, is from a breed they call Belgian Blues, and they are a cow that is specifically bred for one genetic defect. there's something in your body called myostat that normally tells your muscle growth to shut off. It's like, okay, we have enough muscle, don't make any more, let's focus on making fat or something else for a healthy body. These guys, that has been completely disabled. Their muscle growth never shuts off, and so they have 2 to 3 times the muscle mass that they should have. So they have almost no body fat. So that makes them very popular in the beef industry because you get a lot of meat and not a lot of fat content. But because they have way more muscle than they should, they actually have a lot of health problems as a result of that, and they don't live for a super long time.
So these are examples of genetically modified organisms, or GMOs. So the way these fish are actually made is genetic sequences, that is the DNA from bioluminescent jellyfish, have actually been extracted and placed into these fish in order to make them these bright colors like orange and yellow, and also bioluminescent. And so that's sort of a consumer-oriented version of genetic modification, but there are more practical health benefit ways of using genetic modification, such as in corn and wheat. And Kent can tell you more about corn.
So, little wicky tiny blob of disappointing thing was once 10,000 years ago what people were eating, and then but over time we got more kernels and larger kernels.
And so what that is called is artificial selection. So what I just mentioned with the fish and the jellyfish is what's called transgenics, where they're directly inserting genetic sequences into a different organism. Artificial selection is a more traditional version of genetic modification, wherein over many generations you actually breed the best of a particular crop or animal in order to produce a better, stronger, or healthier crop, such as is the case in this wheat. So if you want to look right over here, we have what is essentially the wild type wheat. So this is a grass, the ancestor of modern wheat, and over many generations farmers actually bred this wheat into the modern, more robust form we see today. But on top of artificial selection, it can actually be intermingled with transgenic modification. So you can increase the nutritional value, which as has been done in wheat, or increase the nutritional value in rice, which has been done in India and East Asia, which Kent can talk about.
So this is our standard white rice, and then this is what is called golden rice. Now in India they bred
the staple crop.
Which rice is a staple crop in India, which but the downside with rice is that they don't have a lot of vitamin A. So what they did was genetically modify rice to have more vitamin A, and that's why it's a golden color, such a golden color.
And what that does is the lack of vitamin A, so vitamin A deficiency, actually causes blindness in children particularly. So there's about 250,000 cases of vitamin A deficient blindness in India every year. And since the introduction of golden rice, it's been reduced significantly. So there are massive health benefits to genetic modification of crops. We don't have any examples here, but one of the biggest and probably most important success stories for genetic modification was the production of insulin in the 80s. So before the 80s, insulin was produced primarily in cows and pigs and had to be extracted from them. But in the 80s, they genetically modified E. coli to produce insulin to make it cheaper and more efficient for people with diabetes. So that's been a big boom. There are a lot of different ways you can actually modify organisms. So we have the traditional version, which is artificial selection, which is essentially human-guided evolution. We have mutagenesis, which is essentially you blast seeds with radiation or induce chemicals to induce changes in the genetic sequence. You can use RNA interference to block specific genetic sequences from occurring, or you can do what we've been talking about, which is transgenesis, where you take sequences from one organism and place them into another organism. And there are all sorts of benefits to doing genetic modification. These include things like reducing environmental impacts. So the more densely packed you can get your food, the less land you have to clear. It can also feed more people, and with the help of transgenics like we've been talking about, you can increase nutritional output as well as make things like pesticide-resistant corn, which in turn can reduce the amount of pesticides you're actually using on the crops. There are some downsides of genetic modification, namely loss of genetic diversity. So one of the big drivers of evolution is genetic diversity. The more diverse the population is, the more adaptable it is to new environments such as disease, drought, floods, climate change, things of that nature. So over here we have this variety of fruit. So bananas are essentially, all these Cavendish bananas that you're familiar with are essentially all clonal. So in the 80s there was an outbreak of disease among bananas that killed virtually all the bananas. Yeah, all of them. I'll let Kent talk about the bananas.
So bananas basically all went extinct.
So yes, what's this one doing here?
So what happened was we went to the wild and found a different variety of banana, and we basically cloned all bananas.
So these bananas are virtually all clones of one another because so many of the bananas were wiped out that they reproduce them through cutting from a very small ancestral population. And what that's actually done is significantly reduce the genetic diversity in bananas, which continues to make them highly susceptible to things like disease and environmental change. While something similar hasn't yet happened to apples, apples are similarly susceptible to this sort of perturbation, because apples, there's only 4 major variety of apples that dominate the world market, and essentially each breed of apple is very genetically similar, and so this makes them also very susceptible. So while there are some shortcomings regarding the loss of genetic diversity in these food crops, overall this sort of genetic modification is very beneficial because it gives us things like higher yield corn, higher yield wheat, higher nutrition rice, pesticide resistant corn, and just in general more food for less land, which is necessary for a growing population. So regardless of some of the shortcomings, it's still a very beneficial technology, and it also gives us glowing fish, which is really cool. So, yeah.
About vaccines, kind of just about how the flu shot is so important and how you have to get a new one every year, and because it changes. Also talking a little bit about herd immunity and how vaccines work, and how important they are, and then showing people the signs and symptoms or what these diseases look like and why we immunize against them.
Okay, so why do we have to get a flu shot every year?
Because the flu germ, so to speak, mutates, and every year it's kind of a different thing, so they have to change the vaccine every year, and that's why you have to get one every year.
Why does the flu virus sometimes not work? Or the flu vaccine sometimes not work?
Because sometimes they just don't get it right, but it usually still will help you not get as sick as you would typically get if you did not have the vaccine.
Okay, and what are some of the symptoms that we should look for?
For influenza?
Yes.
Cough, fever, shortness of breath, lots of nasal drainage, headaches, sore throats, stuffy heads. It's just kind of like all the other upper respiratory illnesses, but it's worse.
Okay. And you mentioned herd immunity. Could you explain that a little bit?
Well, I have a great visual here. Okay. So what happens is if nobody gets vaccinated and you get a couple of sick people, then everybody gets sick. The more people you have vaccinated, it shows that the less people in population get sick, and everybody needs to get immunized so that the people who cannot have the immunizations, like if they're immunocompromised or too young or on certain medications, they cannot get immunized, so everyone else needs to be immunized so we won't get those people sick.
Thank you. Is there anything else you want to let us know about vaccines?
They're just super important, and everybody should follow the schedule as recommended by physicians.
Thank you.
You're welcome.